Hi, in this particular playlist we're going to be looking at the 2017, so that's last year's Edexcel paper 1 non-calculator paper, and it's actually for the higher tier. If you want to have a go at this paper, please do follow the link below in the description and you'll be able to download this and have a go. I'm going to aim for each of the videos to last about 20-25 minutes, so if you do have a go at each of the questions you should be on for about a focused hour's worth of revision. Okay, so let's move on then to question number 1, and question number 1 shows a scatter graph. In this particular case, we've got a scatter graph showing the maximum temperature and number of hours of sunshine in 14 British towns on one day. And then the first question is, it says one of the points is an outlier. So all they mean by an outlier is one that just doesn't correlate with the rest of it, and that's this particular one over there. So the coordinates for that point are 10, 19. Okay, and then it says for all the other points write down the type of correlation. Well, all they mean by that is it a positive correlation, in which case the points go this way, a bit like a tick, or is it a negative correlation where they would go the other way, something like that. So in this particular case it is a positive correlation. Okay, so let's move on then to part C. Now with part C it asks us to estimate the number of hours of sunshine in the town on this day where the maximum temperature is 16.4. In order for us to do that, what we need to do is draw a line of best fit. So we just simply take our ruler and draw a line that correlates roughly in the middle with all of the points. Now you appreciate I'm doing this on a video, so I made a little bit of an error there. I could probably bring it down a little bit and have it slightly steeper, but you get the idea that really all they're interested in is that the number of hours of sunshine are going to be related directly to the temperature of 16.4. So it's this temperature along here. So if I draw a line straight across there, and then I can read off the number of hours of sunshine. Now in this particular case I think it's going to be around about 12.8, so I'm going to write that into this as being 12.8. Okay, now actually if you look in the mark scheme for this particular question, it gives you a variation of between 12 and 13 hours, and that's absolutely fine. Okay, so let's move on to one of their standard type questions. It says the weatherman says temperatures are higher on days when there is more sunshine. Well, yes, that's true. However, it says, does the scatter graph support what the weatherman says? Yes, it does support. However, I think one of the points of these sorts of questions is it's kind of not enough data really, because they've mentioned in the front it's only 14 towns and on one day. So I would probably make the point it's just not enough data to support this. Okay, and very typically with these sorts of questions that's the kind of thing they want you to put in as an answer. Okay, let's move on then to question number 2, and we've got one of the standard questions that you're going to get quite a lot in, particularly in non-calculator papers, and express 56 as a product of its prime factors. So all you would do with this is just simply do a normal factor tree. Now the way I do them is I always divide, if I can, by 2 or 3 straight away. I don't try to do anything else, because what I end up with is, in this particular case, all of my prime factors along this edge, and it just gives me that little bit of confidence I'm not going to miss anything out. So when I write it out as a product of its prime factors, I'm going to write 56 equals 2 times 2 times 2 times 7. So let's just check that. 2 times 2 is 4. 4 times 2 is 8, and 8 times 7 is 56. So I know I've definitely got myself 2 marks for that particular question. Okay, so let's move on then to question number 3. And again, fairly simple, well not simple, but fairly straightforward question that you're going to get a lot of in these kind of papers, where it says work out 54.6 times 4.3. Okay, you need to really get into the habit of putting in the decimal point after you've done the calculation. So however you do it, what you should be doing is doing 546 times 43. Now if you do that, you can either do that as that kind of algorithm, or sometimes I see people using this kind of partitioning thing where you've got 540 and 6, and then you've got 40 and 3. Remember, what I'm doing is I'm just multiplying it without the decimal point. Now however you do that is perfectly down to you. I've no issue at all. However, you should end up with the numbers 2, 3, 4, 7, 8, and then all you would do is put the decimal point back in, and you can see here it's moved 2 places, once, twice there, so I'd move that back in and it becomes 234.78 as my answer. Okay, hope that's all right for you. Let's move on then to question number 4. And question number 4 is a show that question. So the important thing with this is they're not asking us to calculate, they're asking us to show something. So what they're saying is the area of the whole square ABCD is 10 centimeters squared, and we've got to use the information we've been given, all these 3's and x's, in order to show that this is true. So let's just have a look at that. Well, if we're working out the area of a square, what we're doing is working out this plus this plus this plus this. Okay, so what I'm going to say is that the area is A plus B plus C plus D, and that's going to equal 10 centimeters squared. So let's look at each of those in turn. So A, the area of A is going to be 3 times 3, which is going to be 9. The area of B is going to be 3 times x. Okay, so that's going to be 3x. The area of C is going to be x times 3, which I could write as x3, but it's not really the way we do things. We need to write that also as 3x. And then finally I've got D, which is x times x, which is going to be x squared, and that equals 10. Okay, and really that's the end of it. All we need to do now is just rearrange that and make it look like this. So the first thing I'm going to do is I'm going to bring these x squared and this 3x and 3x together. So I'm going to get x squared plus 6x, and that's good because it's the beginning of this. And then finally I've got plus 9, and that equals 10. Okay, well, in order for me to make it equal to 1, I need to take this 9 over to the other side. So I'm going to minus 9 from both sides, and I get x squared plus 6x equals 1. And that's the end of that particular question. Hope that's okay for you. Like a lot of these things, is that you need to make it as clear as you possibly can, particularly for 3 marks in that particular question, to make sure that you're demonstrating to the examiner that you understand what it is that they're asking you to do. Okay, let's move on then to question number 5. And question number 5, we've got a rectangular frame is made from 5 straight pieces. Well, let's just check that to be true. So we've got this piece, that's 1, 2, 3, 4. So there's 4 pieces around the perimeter, and then 1 piece across the middle. So they're absolutely right. It's made of 5 pieces. And then it says the weight of the metal is 1.5 kilogram per meter. Work out the total weight of the metal in the frame. Okay, well, I think in order for us to do that, what we have to do is we have to work out the total length. And you'll notice they've been very helpful. They've given us that these are 12, which also means this is 12, this is 5, and this is 5, which is great. The only thing that's left to work out is this diagonal along here. In order for us to do that, we can just use Pythagoras. So what we can say is, if we draw a triangle, I'll draw it the same way round as it's given to me in the picture. So that's a right angle, and this is 5, and this is 12, and I'm going to call that x. Okay, so x squared equals 5 squared plus 12 squared. Well, that's going to be equal 25 plus 144, okay, and that's going to be then equal to 169. So remember that equals x squared. So if I want to find the value of x itself, I need the square root of 169, and that equals 13, because 13 times 13 is 169. Okay, so we've now got all of the information that we need in order for us to work out the total length. So the total length is going to be the 4 sides that we talked about. So it's going to be this one plus this top one, which is going to be 24. And then the 2 sides here, which is 5 plus 5, is going to be 10. And then also this diagonal piece, which we've just worked out, which is going to be 13. Okay, if we add all of that together, we're going to get a total of 47 meters. So in other words, there's 47 meters worth of framework, metal framework that's been used to make this particular construction. Okay, so if we want to work out the weight of the metal, it says the weight of the metal is 1.5 kilograms per meter. So really what they're asking us to do is to calculate 47 times 1.5. Okay, now I've got my ways of doing that, and you know, we need to be a little bit careful which algorithm you use, as we mentioned before in the calculation, multiplication calculation question. What I'm going to do is I'm going to use this particular method at the side here, and just to show you that the way I would do it is I would do 5 times 7 is 35, 2 left over, 4 5s are 20, plus 2 is going to be 20, 4 5s are 20, is, oh sorry, 35, so 235, okay, and then I'm going to put a 0 in here, 1 7 is 7, plus 4, and add all of that up, and that's going to give me 705. Now bearing in mind it's actually the decimal point has been moved one place, so that's going to be 70.5. So the total weight of metal is going to be 70.5 kilograms, and that will answer that particular question. Okay, hope that's okay for you. Let's move on then to question number 6. So in question number 6, we're back to a little bit of algebra, and in this particular case we're asked to prove or show that these 2 lines are parallel. Okay, so as soon as you see that, you need to remember that what we're actually looking at is if it's parallel. So I would put a statement here that if parallel, the gradient is the same. Okay, so what we can say is if we look at the line 1, so we've got L1 equals y equals 3x minus 2. Okay, the gradient is 3. This is the gradient here. Okay, and all we need to do with L2 is rearrange it to be able to show that the gradient is the same. So let's just have a look at that. With L2, that equals 3y minus 9x plus 5 equals 0. Well, really all of this is just a way of asking you to demonstrate how you can rearrange this formula to get the gradient. Okay, so the first thing I'm going to do is remember that we need to show it as the standard form is y equals mx plus c. So that's the standard form. And what I'm going to do is rearrange this in exactly the same way. In order for me to do that, what I need to do is take this minus 9x and this plus 5 over to the right hand side. Now I'm just going to skip a couple of steps here because really with rearranging these sorts of formulas you need to make sure that you appreciate that what we're doing is, in this particular case we've got minus 9x. Well, I'm going to add 9x to both sides, and with this plus 5 I'm going to minus 5 to both sides. Now those two will cancel out, and on the left hand side I end up with 3y, on the right hand side I end up with 9x minus 5. Okay, so I have just skipped that. I've done that in one step where really you could do that in 2 steps, but hopefully you get the idea that we're just moving the some of the terms over towards the other side of the equals sign. Okay, so I've got 3 values of y equals that. So what I need to do now finally is divide through by 3. Now if I divide through by 3, on the left hand side I get y, which is brilliant, it's what I'm after. On the right hand side I can write that as 9x minus 5 over 3. Now do remember that this means that both of these terms are divided by 3. And also remember that we're not trying to make life, we're not trying to solve anything or do anything. All we're trying to do is just prove that the gradient is the same. So I'm going to write that as y equals 9x over 3 minus 5 over 3. So 9 divided by 3 is 3x, y equals 3x, and 5 divided by 3, I'm just going to leave us 5 over 3, which is absolutely fine. If you want, you could change that, but it's perfectly reasonable as it stands at the moment. So what we're saying is that gradient of L2 is also 3, in which case both lines must be parallel. It doesn't really matter where they intersect the y-axis. This is the y-axis intercept. Doesn't really matter. It's just showing that those 2 lines are parallel. Okay, I hope that's okay for you. I'm conscious of the time. It's now about 16 minutes into the video, so I'm going to crack on just a little bit further and see how far we get with the next few minutes or so. Okay, so let's move on then to question number 7. And question number 7 deals with mean, okay, or mean average. It says there's 10 boys and 20 girls in a class. Class has a test, mean mark for all the class is 60. Okay, so let's just stop at that particular point. The mean mark for all the class is 60. So if we have that and we know the number of people in the class, that's 10 boys and 20 girls, so 30 in total, it will allow us to work out the number of marks in total that the class has been awarded. So that's all the students together, all of their marks added up. Okay, so if we look at this, then I can write class mean. Now the way I remember these things is total over number. Okay, I'm aware that there are different ways of remembering it, but nonetheless it works for me. So what we're saying is the total I don't know, but what I do know is that the class mean is 60, which is what it tells me. The total I'm trying to work out, and the number of students in the class is 30 altogether. And I put therefore the total must be 60 times 30, which is going to be 1800 marks. Okay, so all of the students altogether were awarded 1800 marks. Okay, let's have a look then at the next bit of information it gives us is the mean mark for all the girls is 54. Well, that's great because I know there's 20 girls and I know their mean mark, so I can do exactly the same thing again. And rather than having class mean, I can work out the girls' mean. Okay. So that's going to be equal again to the total over the number. And I would always try to encourage you, please, to try to remember to keep writing these formulas. However you remember them, if you keep writing them, it's going to really help your revision and going to really help you to remember it. Okay, so let's do the same exercise. So we're told that the mean mark for the girls is 54. That's going to equal the total number of marks that the girls were awarded, but we know there's 20 of them. So I can then work out by multiplying 54 and 20. Now I know that's 1080, but again you might need to do your own calculation. So therefore the total for the girls is going to be 1080 marks. Okay. Well, that's great because now I'm in a position where I can work out the number of marks that the boys actually got. Okay, so the boys' mark must be equal to the total mark, which we've worked out, minus the girls. Okay, so that's going to equal 1800 minus 1080, so that's going to be 720. All right, so I've now got all the information I need to be able to work out the mean mark for the boys. I've got the total number of marks, and I know that the total number of boys is 10. So therefore, again, the boys mean, and I know I'm writing out this this formula again, but it always helps me to remember I've got the total and I've got the number. Okay, so in this particular case, the total number of marks for the boys is going to be 720, and the number of boys is 10. 720 divided by 10 is 72. Okay, so the mean mark for the boys is going to be 72. Okay, hope that's all right for you, and let's move on then to question number 8. So question number 8, we're dealing with standard form. Standard form does come up. It's a fairly popular question. It's becoming actually more popular, I think. But all we're saying really is we're going to write this as an ordinary number. It's told us the decimal point has moved 6 places in this direction. So this number is very, very, very small indeed. So if it's got 1 jump here, it means that there's then going to be another 5 zeros in front of that jump. So if I want to write this down, I'm going to write it as 0 point and then 5 zeros, 1, 2, 3, 4, 5, and then 7, 9, 7. Okay, hope that's all right for you. And then it says work out the value of that divided by that and give your answer in standard form. Okay, so let's just have a look at that for a moment. What I normally do with these kind of questions is I split them up into the bits I need. So I keep the standard form separate to the actual calculation. So what I'm going to do is I'm going to write 2.52 divided by 4, and then the standard form of it is going to be 10 to the 5 divided by 10 to the minus 3. Okay, so that gives me then something I need to work on. I've got 2.54 divided by 4. And again, you might use a standard or a slightly different way of calculating this. To me, all I would do is I would do it just as a straightforward short division calculation. So that's going to give me 0.63. Okay, so I know then that this calculation is 0.63. The standard form part of it is 10 to the 5 divided by 10 to the minus 3. So just be careful a little bit about this, because what we're going to do is we're going to minus these indices. So I end up with 5 minus, because it's a division, minus 3. Well, where you get two minuses together, so it's going to be, if you like, 5 minus minus 3. Where you get these two minuses together, it becomes a plus. So it actually ends up as 5 plus 3, which is 10 to the 8. Okay, now always with these questions, they're usually 2-mark questions. So at this point, you're going to get 1 mark. And the reason being is because it's not in standard form. You need to be able to make sure that the first number is between 1 and 9. In this particular case, it's 0. So what I'm going to do is move the decimal point back a bit, and I'm going to get 6.3. Now, because I've done that, I also need to change the index there and move it back to 7. So the answer to this particular question is going to be 6.3 times 10 to the 7. Okay, hope that's all right for you. We're 23 minutes into the video, so I'm just going to crack on a little bit longer, and let's have a look at question number 9. So question number 9 deals with Jules buying a washing machine. 20% VAT is added to the price. Jules then has to pay a total of 600. What is the price? So what we're saying is that £600 equals 120% of the net price, because the net price was 100%, and then I've got 20% VAT on top of that. Okay, so I end up with £600 being 120% of the net price. Okay, so let's just change that for a minute, because with percentages, you need to change those to decimals. So I'm going to change that to 1.2 of the net, and that's equal to 600. So if I want to work out the net, I just simply divide through by 1.2. Okay, now that's actually where some people come unstuck, this sort of mix of a fraction and a decimal in there. So the way I would do that is I would make this bottom number a whole number. So in order to do that, I'm going to move the bottom by 1 decimal place. So the bottom becomes 12. Now, because I've moved by that 1 decimal place, I need to also add a 0 onto the top here. So that becomes 6,000. Okay, so 6,000 divided by 12. Well, 12's into 60. This bit at the beginning here is 5, so that's going to be 500. Okay, and that equals the net. All right, so the net price is going to be £500.